All right, so here we go. We're going to talk about writing equations to lines. All right, and whenever you're asked to write an equation of a line, this is the equation we're going to go to. It's called the point slope form of the equation. Reason it's called the point slope form because it will tell you the slope of the line and it will tell you a point on the line. And if we know a point on the line, we can always use the slope to find the second point to draw the line. All right, and here it is, y minus y sub 1 equals m times x minus x sub 1. Okay, now when we have this, all right, the y sub 1 and x sub 1, this point here and this here, those are the point on, okay? The other x and y, this y and this x, are going to stay x and y. Remember, we have to have, for an equation, we got to have an x term and a y term. We're going to have an x and a y in it, unless it's vertical or horizontal. Yes, sir. M is the slope. Okay? So this x and this y are going to stay x and y. We're going to fill in here and here. This represents the point on the line, and then M, like always, is the slope. Okay? So in order to write an equation of a line, we need two things. We need to know the slope, and we need to know any point that is on that line, any ordered pair that's on that line. Okay? That's the things we need to know. All right, so here's how this is going to work. We're going to write the point slope form, and then the slope intercept form of the equation of a line with slope as a slope of 2, and it passes through the point -1, 3. All right, so we want to write the equation of the line that has a slope of 2 and passes through the point -3. And what we're going to do is we're going to use this equation, y minus y1. All right. So that's the point slope form. So the first thing is they want to know the equation in point slope form. This is just a matter. We've got the slope and we've got the point. Here's the x. Here's the y. So it's going to be y minus, and this is really x1 and y1. Minus y1. Well, y1 is 3, so it's going to be y minus 3 equals m, the slope, tells us it's 2. And then x minus a -1. The x1 is -1. So anytime we have minus a negative, it turns to a positive. All right, so that is the equation in point slope form. All right, right there. That answers the A part. The next part says they want to put it in slope intercept form. Slope intercept form is whenever we solve it for y, get the y by itself. So all of these like this that we put into point slope form, there's two steps. First, we've got to get rid of the parentheses by distributing the 2. So I distribute that 2. So this becomes y minus 3 equals 2x plus 2. Then to get y by itself, I add the opposite of that number right there. Minus 3, I'm going to add 3. So I get y equals 2x plus 5. That's the slope intercept form. So that's the second part. This is the first part. This is point slope. This is slope intercept. All right. So when you're working through your assignment, you have to pay attention. Does it ask for the point slope form or does it ask for slope intercept? Okay? How do I shrink it back out? I keep getting bigger. There we go. All right. All right, here, let's look at this one. All right, a line passes through the points 4, -3, and -2, 6. Find the equation of the line. All right, now there's a couple of ways here. Now, for point slope form, in order to write the equation, we need to know two things. We need to know one point on the line. In this case, they give us 2 points on the line. Now, when you have more than 1 point, it doesn't matter which point you use. It's all going to work out the same. And I'll show you that with this one. So this one, they give us the point -2, 6, and they give us the point 4, -3. Now, there are two different ways we can find the slope. The second thing we need to know is the slope, which they do not give us. But anytime they give us 2 points, we can find the slope. We can either use our slope formula, which was y1 minus y2 over x2 minus y2 minus y1 over x2 minus x1. Or because they give us a graph, we can count it out. Right? I could count out to go from this top point down to this bottom point. I go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, and I go over 1, 2, 3, 4, 5, 6. I go down 9, which is -9 over 6. Now let me go to the. Okay, so this is the information we have. The 2 points were -2, 6 and 4, -3. I counted out the slope of -9 over 6, which we do have to reduce that. That will reduce by a factor of 3 to -3/2. Or I could have used my slope formula. Y2 minus y1 over x2 minus x1. That would have been -3 minus 6 over 4 minus -2. That's -9. 4 minus -2 is a positive. Notice I get -9/6. So I can count it out if they give me the graph. Most of the time they're not. Then I have to use the slope formula. All right, now I'm going to erase that. All right, so now we have the slope. And we have 2 points on the line. So let's use this point first. So I just plug in y minus 6 equals -3/2 is the slope. X minus a -2 would be +2. Now, generally speaking, whenever we do this, they're going to ask us to put it in a slope intercept form. Okay? But that's point slope form. So let's go ahead and distribute. So we're going to multiply. Y minus 6 equals -3/2 x. -3/2 times 2. That's why we have these calculators. If you don't know, understand multiplying fractions, right? That's like 2 over 1. We'd multiply the numerator. -3 times 2 is 6. I'm going to do it off to the side here. -3 times 2 is -6. 2 times 1 is 2. -6 over 2 simplifies to -3. All right. Now we just simply add 6. and we get y equals negative 3 halves x plus 3. If you have trouble adding and subtracting with positives and negatives, then use your calculator. So there's the equation of that line that we saw. Now, notice, I'm going to erase all this. I'm going to leave that answer, and I'm going to use the other point just to show you it doesn't matter which point I use. Say I'm going to use this point this time. This would be y plus 3 equals negative 3 halves x minus 4. Now that point slope formula looks different. Various point slope formulas that look different can always be the same line. They can look different. Once we put it in slope intercept form, it has to look the same. So notice I distribute that. So I've got y plus 3 equals negative 3 halves x, and then negative 3 halves times negative 4. Negative 3 times negative 4 is 12. 2 times 1 is 2, and that is 6. Positive 6 plus 6. Now notice I subtract 3, and notice what I get. Y equals negative 3 halves x. 6 minus 3 is 3. I end up with the exact same slope-intercept form. So if you're given 2 points, it does not matter which point you use. Okay? Any questions? No. All right, so this is just a sort of quick review of all the equations we've looked at. Let me zoom in so you can see it good up there. AX plus BY equals C, that was the general form where the X and the Y were on the same side. Whenever we had Y equals a number, that was a horizontal line. X equals a number is a vertical line. Slope intercept form, Y equals MX plus B, and now today the point slope form. Okay? All right, so here is just a problem. We're going to come up with an equation. Write the slope-intercept form of the equation of the line shown. Use a function to predict the median age of the U.S. population in the year 2020. So that was last year is what they're wanting us to predict. So remember, anytime you see write an equation, we are going to our point slope form. Y minus y1 equals m times x minus x1. So what do we need? We need a point in the slope. So is there enough information here to find a point in the slope? Well, if I look at that second chart there, it gives me 2 points. So I'm good. I've got points to use. I can either use 30, 35.3, or I can use 10, 30. All right. These bar graphs really doesn't matter here. It tells us the median age, and it's just the median age of the U.S. population. What's median? Does anybody remember from mean, median, mode what median is? Is if you listed all the numbers, it's the one in the middle, right? So if you listed all the ages of everybody in the United States, the middle age is going up every 10 years. In 1970, it was 27.9 was the middle age of people. Now, in 2010, it was 37.4. So what that tells you is people are living longer, right? There's more older people than there were back in 40 years ago. So we've got the 2 points, 10, 30, and the other point is 30, 35.3. Okay, and they want to know an equation to predict the median age of the U.S. population in 2020. So this is what this will do. Okay, so we've got to come up with an equation. All right, first thing we need to do, we've got a point. We've got 2 points. We need the slope. So the slope, we're going to subtract y minus y, so 35.3 minus 30 over x minus x, 3 minus 10. Now, let's go back to that chart. What does 3 and 10 mean? I'm sorry, that was 30 minus 10. That's 30. I got to write down my points correctly. 10 and 30, if I look at this chart, it's the years after 1970. So 10 really means what? 1980. 30 means the year 2000. All right, it tells us this first number is the number of years after 1970. Okay, so I have to know that when I get to my final answer. All right, now what's that slope going to be? That's going to be 5.3 over 20. And I'm going to put that in my calculator. Now, on this particular, when you get to the application type problems, usually instead of a fraction for the slope, they want you to go ahead and divide it out and get a decimal. And let's see, 5.3 divided by 20 is 0.265. Now, what does that 0.265 mean? Let me make sure I've done that correct. All right. What that means is every 10 years, or every year, the age is going up by 0.265 years. Does that make sense? Okay. Every year, the age is getting better by 2 points. That means in 10 years, it'll go up by 2.65 years. All right. Now, let's come up with this equation. I'm going to use this first point because it doesn't have a decimal in it. So I'm looking at y minus 30 equals 0.265 times x minus 10. Now we just do the two things. We distribute. Y minus 30 equals 0.265x minus 10 times 0.265 is 2.65. And then I just have to add 30. So I end up with y equals 0.265x plus, what is negative 2.65 plus 30 is 27.35. So this is our equation for that line. Now, if you'll notice, if I go back to this, what does it ask? It wants us to make a prediction. All right? Whenever they're asking you to make a prediction, basically they want you to come up with the equation, and then they want you to plug into the equation something so that you can make a prediction. All right, so we want to know what was the population in the year 2020. Well, what am I going to plug into my equation? Am I going to plug in 2020? We're not going to plug in 2020 because remember on the chart, this was the number of years after 1970. So how many years is 2020 after 1970? 220 minus 1970 is 50. So what I do is I'm going to go right here. That's 50. I'm going to take that 50 and plug it in for x. When I do 0.265 times 50 plus 27.35 That's going to tell me what the average median age is in the year 2020, which was last year. So 0.265 times 50 plus 27.35 is about 40.6 years. So the answer to that question is 40.6. So we came up with an equation, and then we substituted into the variable of x to make a prediction. All right, 40.6. There's the problem. All right, so now we're going to talk a little bit about scatter plots. A scatter plot is just a collection of data points. Instead of a line, you just got a bunch of dots from different sets of data. Like if you got the NFL playoffs this weekend, if you want to know something like Patrick Mahomes each week of the season, how many passes he threw, week 1, 35 passes, week 2, 40 passes, and you use those as ordered pairs, the number of passes, the week, and the number of ordered passes, and then you plot each dot on a graph. That is now a scatter plot. All right. From the scatter plot, we can see trends. We can see if he's throwing more passes each week, about the same, if he bounced up and down. All right. Whenever we have a clear relationship, it's called a correlation. We use that to determine if there's a relationship between two variables. Okay. So here is example of a scatter plot. This is the one. It says a score. People took a test on a prejudice test, and they compared it to the years of education. All right, and you'll notice there is somewhat of a trend. The more the dots line up into a single line, the more of a trend there is. The more scattered they are, the less of a trend, and less than we can deduct. And what we could say is these two things are not correlated. Here, the years of education and the score on a prejudice test are somewhat correlated. It's not directly correlated, but somewhat. Basically, it's saying the more years of somebody's education, generally the less prejudiced they are on this test. All right. So this would be a weak correlation. It's not real strong because they sort of make a line, but it's not an exact line. Okay. A regression line is a line of best fit. So if I wanted to draw a line here, I could draw a line that would be closest to all of them. So I could draw a line kind of like that right there. That would sort of be in the middle of them, and then I could use this line to create data, but that's called a line of best fit, and I probably needed to make it a little more. I can't draw straight on this with this mouse, but a little more like that is how it should have looked. Anyway, that's a line of best fit, a regression line. All right, so correlation coefficient. All we're really worried about is we want to be able to tell if something is positive correlated, negative correlated. That's just like slope. An uphill line is positive, a downhill line is negative. So a positive correlation is a group of points that go uphill, that work their way uphill as you go to the right. A negative correlated means they're working their way downhill. Perfect positive correlation means it pretty much makes a straight line. It lines up in one line going uphill. Perfect negative lines up going downhill. So here you go. First and last ones here are examples of perfect correlations. All right. A is a perfect positive correlation. Hello? Hey. Yes. Oh, he hasn't shown up. I don't know if he's here today or not, but he's not here. I didn't look today to see. I haven't seen him all day, but yeah. So I can look. My computer's on the other side of the room, but all right. All right. So as you can see, the first and last ones, they line up perfectly in line. So they are perfect correlations. The one that's going uphill is a positive, the downhill one is negative. Now, if you look at the second, B and F, these two, these are just strong positive, strong negative. They do sort of all bunch up around a line, but they're not perfectly in alignment. These two are weak correlations. This is still positive because as you work your way to the right, they tend to be going uphill. This one, as you work your way to the right, they tend to be going downhill. And then this one right here is no correlation at all. And that's basically all I want you to be able to do is look at a chart and see, is it strong, perfect, weak, or no correlation at all? Positive or negative. Okay? And that is it. So I will activate